Ladies and gentlemen, boys and girls, children of all ages, we have been working on greatest common factors and simplifying fractions for the last couple weeks. You've been introduced to it with short videos as an introduction. You should already know how to simplify fractions because that was last year's stuff. That's why I showed it in a video. But since many of you were asleep during the videos, we're going to go over a little bit of that. We're going to start today with greatest common factor. Greatest common factor is the biggest factor that two or more numbers have in common. For example, let's take 18 and 6. We are going to find the greatest common factor between 18 and 6, or of 18 and 6. We have already found factors when we worked to see if we could find prime and composite numbers. We've already done this, when we had to find prime and composite numbers. When we're finding factors of a number, Emily Kate, what is the first factor pair we start with? Good. We're always going to start with the 1, because they all have 1 as a factor. 1 times itself will equal it. This is where the divisibility rules come in handy. Divisibility rule for 2, 3, 5, 10. Those are all pretty handy to know 6. I'm just saying. So let's go back to 18. Let's go back to 18. I need a factor pair for 18. DJ.
6 times 3.
6 times 3. Any others for 18? Joe Michael.
2 times 9.
2 times 9. Any other factor pairs for 18? Bueller? Bueller? You are correct. There are no other factor pairs for 18. Now let's go to 6. Factor pairs for 6. Aiden.
2 and 3.
2 and 3. Any other factor pairs for 6? Jaden.
2 times. Oh, no.
Never
I
mind.
already said 2 times 3.
Already said 2 times 3. Good. Good. Aiden.
3 and 2.
3 and 2. With that property of multiplication where you can like move them around and stuff, those are the same. So we're just going to leave it up there once. What's that called? Commutative property. I always forget the names of the properties. DJ?
Would 6 divided by 3?
No, because we're multiplying together. We're finding factor pairs. 2 numbers that multiply together to equal that number. That is it. Now we have the word common. Common tells us like what they have in common. Like, what do Luke and I have in common? Well, we're both wearing hats. We're both male. You know, what they have in common. So common here is we're going to find what they have in common. What in each of these factor pairs do they have in common? They both have 1 in common. Oh, somebody from France is calling me. Wow, oui. What else do they have in common? Eli K.
3s.
They have 3s in common.
2.
Maddie D.
6.
6 in common. The University of Maddie.
2.
They have 2 in common. So what they have in common is 1, 2, 3, and 6. These are our common factors. Now, when it says greatest, it doesn't mean, man, you're the greatest student I've ever had. It means the biggest. The biggest factor that is common to both. And what is the biggest factor that is common to both?
6.
6. So if the assignment asked you, hey, find the greatest common factor, the answer for these 2 numbers it would be the greatest common factor for 6. But what do we use the greatest common factor for? That's an excellent question, Anna. Last week, you had an assignment that looked like this, where you had to simplify these fractions, and they gave you the greatest common factor. So really, it was a pretty easy assignment. You had to divide, and if you can do simple division, it was pretty easy. So that is what we use the greatest common factor for. But if it just says find the greatest common factor, then all you have to do is put the answer. However, if your instructions are to simplify the fraction, then you take that greatest common factor, which in this case is 6. You divide both your numerator and denominator by that greatest common factor. So we said our greatest common factor is 6. Now I put that funny looking 1 around 6 over 6 because 6 over 6 equals 1. If we're dividing by a number that equals 1, then I'm not changing the value, I'm changing how this is written. 6 divided by 6 is
1.
And 18 divided by 6 is
3.
And the cool thing here is, if you write this down, 6 divided by 6 is 1, 18 divided by 6 is 3. It's there already. Now, a suggestion for you is not, when you list your factor pairs for a problem, don't erase it. They may show up later. Your warm-up today is going to ask you to compare which of these fractions is equal to 3/10. It's really pretty easy, but simplifying it is the best way to find it. And those that actually take the time to simplify it are getting hundreds. Those that just pick answers are getting, what's the low? Less than 1. 0. That's what I was thinking of. All right. So let's look at another pair of numbers. 7 and 12. We're going to find the greatest common factor of 7 and 12. At least those of us that are paying attention to Mr. McMurdo are going to find the greatest common factor for 7 and 12. Well, we'll start with, what do we start with, Kara?
1 times 7.
1 times 7. Okay, what else for 7? Help me out here. What other factor pairs for 7? Good, 7 is a prime number. So since it's prime, it only has 2 factors, one in itself. Let's look at 12, Eli A. What do we want to start with for 12? 1 times 12. Knocking out the difficult ones. Liam. 4 times 3. Kara.
2 times 6.
2 times 6. Where are the rest of your hands? We're multiplying together to equal 12. Come on now. Jaden? Somebody already took it.
Oh, wait. Oh.
DJ?
Never mind.
Never mind. Aiden?
Oh, 4 and 3?
That's there.
Oh.
Good, that's all of them. So now we're going to find what they have in common. They have a 1 in common. And that is it. Therefore, the greatest common factor of this is 1. So if it asks for the greatest common factor, it's just 1. If this were a fraction, it asks you to simplify or reduce or put in lowest terms. If the greatest common factor is 1, it's already in lowest terms. You can't lowest terms it anymore. You can't simplify it anymore. You can't reduce it anymore. Let's look at another one. See, I've noticed, Mr. McMurdo, since this one is prime, does that mean it's always already simplified? Well, I don't know. Let's check here. Let's do 13 and 39. We're going to find the common factors of 13 and 39. And as I said, we're always going to start with 1 and itself. So what else do we have for 13? What else do we have for 13? What other factor pairs? Emily Kate? It's prime. Good. It's prime. We be done. 39. What other factor pairs do we have for 39? Luke?
3 and 13.
3 and 13. See, Luke knows his divisibility rules, and he knows 9 plus 3 equals 12. He knows 12 is a multiple of 3. Therefore, i.e., por ejemplo, he knows it's divisible by 3 because the rule for 3 is if the sum of the digits is divisible by 3, then that 3 is a factor of that number. What else for 39? Anyone? 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 Good, that's all. So the greatest, what they have in common, they have a 1 in common. They have a 13 in common. They have nothing else in common. Therefore, the greatest common factor is 13. Now we said 13 was what kind of number? Prime. If this were a fraction, Anna, their greatest common factor is 13, which means we have to divide by a fraction that equals 1. Since the greatest common factor is 13 over 13, Anna, what is 13 divided by 13? 1. Anna, what is 39 divided by 13? 3. See, I could do this. If I have this written down, 39 divided by 13 equals 3. That's cool, man. That's cool. So just because one of your parts of your fractions is a prime number doesn't mean it can't be simplified. Doesn't mean it cannot be simplified. Now you'll do two things today. One is find the greatest common factor. The other one on the warm-up is going to involve figuring out two fractions that are equivalent by simplifying them. Would make it the easiest way to do it.